Hello everyone, welcome to another free online webinar offered to you by Quirino State University. I'm Luther Marc P Sarandi, a faculty of the College of Teacher Education. What I'm going to share with you has something to do with one of the challenges that we educators are facing, and that is to develop the problem-solving skills among our students. So, are you one of these teachers who are currently teaching mathematically challenged students? Or are you one of these students who struggled solving word problems? If yes, then this presentation is for you. So, what we're going to discuss this session is methodology on how to somehow improve the word problem solving skills among mathematically challenged students. So working with me is Ma'am Lovejoy Tuginay. Thank you for helping in preparing this presentation. So let's start. So for more than a decade of teaching experience, here are the common observations among our students. All right. So most of the time, students can solve problems that are presented in the equation form but find it hard to solve word problems. So during discussions, during drills, presenting them equations for them to solve and giving them the relevant information, without doubt, the students can solve. However, when we present the problem in words or offering them word problems to solve, it so happened that they get stuck. They don't know how to start or where to begin. Second, smile if you agree with me. Okay. Second, students tend to stop writing their solutions. Some students tend to present initial solution, write the given in the problem, but after that, they stop. Or even worse, some students don't even try and skip problem solving. They're complaining. Why is that uh, the questions are problem solving? Okay? Or if the problem is presented in the multiple choice question, some students just guess one of the given choices, even in the even if included in the instructions is for them to present their solutions. You notice that at the back of their paper, there's no solution. So what does that mean? There's a possibility that these answers are just wild guess. Right? Or chances are it so happened that they know how to solve the problem, but they find it hard to present or organize their solution. And another observation is that some students just pull out the numbers, choose a random operation or equation, and solve. So, nagmamagic lang yan. Kukunin yung numbers. They randomly select whether they add, they subtract, or multiply without even understanding what the problem is. And if in case it's a multiple choice problem, as long as the answer is one of the choices, then without thinking, they just choose it as their final answer. Now, what are the possible reasons? Okay. Bakit kaya ganito yung ginagawa ng mga estudyante natin? Or bakit kaya ito ginagawa ng mo bilang isang estudyante? First, chances are students have difficulties in reading comprehension. Okay? or they have this problem in conceptual understanding. So basically, if they don't know the principle behind, they get stuck. Okay? Or if they have another interpretation of the problem, then definitely they will fail to solve the problem. Second is that students might have difficulties in organizing their solutions. For simple problems, it's okay. They can do it mentally, but for a more complex problems, they find it hard to organize their solutions. They cannot present, they cannot translate the word problems into equations. Another possible reason is that they might have a difficulty in identifying the appropriate equation and formula. So definitely if they have a conceptual misunderstanding or they have a problem in identifying the principle, then chances are they will also find it hard or difficult to choose the appropriate equation or formula to solve the word problems. Fourth observation is that, or possible reason is that they might be a challenge in manipulating equation, in deriving equations. We all know that not all the time, given the equation, it's always x that is being asked. Sometimes it's a variable on the other side of the equation. So if this is the case, some students find it hard to transpose or simply to manipulate the equation in order to solve what is the unknown. Or sometimes students lack confidence in dealing with numbers, symbols, and mathematical operations. They have this aversion of numbers. Kapag nakakita na ng numbers yan, or nakakita na ng math yan, okay, they just simply say to themselves, hindi ko alam yan, mahirap yan, mahina ako dyan. Okay? So with this attitude, somehow it tend to prevent or it limits their capacity in solving word problems. So ayaw na mag-participate, ayaw na mag-start. Math yan, ayoko yan, hindi ko kaya yan. Right? So this psychological effect of having this negative attitude towards numbers or symbols or even operations somehow contribute for this problem of not being able to solve word problems. So because of these possible reasons, we come up with the possible solutions that we teachers or educators might use, or that you or dear students might also use in improving your problem solving skills. Right? So we have here integration of numberless problems. That is for the teachers. And I guess. So what is this numberless problems? Numberless problems is characterized by putting blank rather than numbers. This is to address the students who just pulled out the numbers in the word problems and trying to create or trying to choose a random operation for them to solve the problems. Okay? But by putting blank, they will focus on understanding the problem first. Solving the problems by simply using random operations will be uh, set aside. Okay? So ang magiging focus muna nila ay intindihin kung ano yung tanong, intindihin ano yung gagawin. And because some observations, ba, habang nagbibigay ka pa lang ng instruction, yung iba is tumitingin ng kagad sa number. Okay? They just focus on these numbers, regardless they are relevant to solving the problems or not. So one way to address this, again, is somehow to give them problem without numbers, okay? So that they can just focus on uh, they focus on understanding the problem first. They focus on conceptualizing how to solve the problem. Okay? And this will address also the problem of these students with a version of numbers. Yung mga ayaw nang nakakakita ng number. Tapos meron pang mga Greek letters that sometimes uh, stop them from trying. Right? And the other methodology is by using the acronym I guess. Okay? Though there are some acronyms offered by books or other resources, I came up with I guess. Okay? And this is what my students are using. So I stands for illustration. Why? Because there are some problems that for students to visualize, okay, they need to illustrate it rather than imagining what is happening in the problem or what is happening in the given problem. And also, by allowing them to illustrate, we teachers will be able to see, will be able to have a feedback on what our students are thinking. Because by diagnosing what they are thinking, then somehow we can address how to solve the problem. Okay? So chances are in the illustration, they might have a different interpretation of the problem. Right? So G stands for givens. Given refers to the relevant information that are needed in order to solve the problem posted. Okay? In the given, ilalagay na rin dyan yung symbol that they represent, okay? Including the corresponding units. Because based on my observation, when students write given, dinalagay lang yung number without even giving what these numbers are representing. Because only to find out, even if they find this information in the problem, chances are they fail to recognize what this given or numbers are representing. Okay? For instance, sa physics, 5 meter per second square, linagay nga nilang 5 meter per second square, pero linagay naman na velocity, which is wrong. Okay? So, doon pa lang, malalaman na natin, oops, dito tayo nagkakaroon ng problema. So, meaning to say, this student might need to work out on identifying first what this given represent, what this information are representing. Okay? U stands for unknown. Okay, so what is being asked in the problem? Because sometimes students were not able to solve the problem for the reason that they even fail to recognize what is being asked. Okay, so if they were able to determine what is being asked, then we have to give credit on that. Right? E stands for equation. So given the principle, given the unknown, so which equation then is to be used for us to be able to solve the problem? So we let our students write the equation, the working equation, for them to solve the problem. And S stands for solution. So given the relevant information as presented in the given and the unknown, and the corresponding equation, we now substitute or plug in the values. Because some students, even though they have this equation, again, they fail to recognize, or they have the problem of manipulating equations. They have the problem of mathematical skills. And lastly, we have this statement answering the problem. Now, to our dear teachers, we can also use this I guess as a rubric in giving points to the works of our students. For instance, if they were able to recognize and correctly illustrate even just simple symbols about the problem, okay, then we give credit on that. So we give 1 point for illustration. If they were able to identify the relevant information with the correct units, with the correct symbol, then we can give them another point for that. If they were able to identify the unknown, then we can give another point on that. If they were able to recognize which equation are to be used or is to be used to solve the problem, then we can give another point for that. And so with the solution, and so with the statement. So giving them the um, points, or giving them the credit for every task that they can perform will somehow motivate them to move further. Right? So with this acronym, so the students who are mathematically challenged, okay, will be given a framework of where to start or where to begin and how to proceed. Okay. Some students might get stuck with unknown, okay? But the thing is, with this acronym, it will give us teachers or even the students feedback kung saan sila nahihirapan. Okay? Because by knowing the part at which hindi mo naintindihan is the starting point. And with that, alam mo kung ano yung i-workout mo. Because the problem is, if you don't understand, if you don't know how to solve, if you don't know how to proceed, at hindi mo alam kung saan ka na-stuck, and that's the worst scenario. Okay? Pero kung nagsimula kang mag-solve at nalaman mo kung saan ka na-stuck, then alam mo kung ano yung i-workout mo bilang estudyante. And for the part of teacher, alam mo kung ano yung mga activities na ipapagawa natin sa mga estudyante para ma-address tong problem na to. Okay? So this, I guess, serves different purpose. For rubrics, for a guide sa estudyante, and also for feedback. It's a feedback mechanism. Okay? Now, let's have a sample. Okay? Sample numberless problem. Okay? A public utility vehicle is started from rest and constantly accelerated at blank meter per second square for blank second. What is its final velocity? So taking a look at this problem, if you notice, wala namang information, walang numbers, right? So on the initial part of developing the problem-solving skills of our students, it will, or it might help that we remove the numbers. Okay. Why? That is again for the students to avoid focusing, solving the problems by simply pulling out the numbers and randomly selecting mathematical operations. Okay? By removing the numbers, they will focus on the situation. They will focus on how to solve the problem. Okay? They tend to conceptualize. Right? So another problem is a tower stands vertically on the ground from a point on the ground which is blank meter away from the foot of the tower. The angle of elevation of the tower of, of the top of the tower is blank degrees. What is the height of the tower? Sir, paano namin i-check yan? Wala namang answer. Okay. Again, this is to improve their problem solving skills. So during discussion, uh, during the exercises, during drills, it might help of presenting first, okay? Initially presenting the problem without the numbers. So that the focus of the students is on understanding first the problem and trying to figure out how to solve the problem by not randomly selecting the the operation to be used and by just pulling out the numbers and using their calculator. So may iwasan natin yon. Okay? Mag-start muna sila na i-conceptualize, na i-analyze kung ano yung gagawin at kung ano yung sinasabi ng problem. Okay? Pero I'm not saying that you stick to this. Okay? Eventually, represent din natin sila na may number. Or pwede mong sabihin sa estudyante mo, you try to figure out, okay, you try numbers na maglagay sila randomly. Okay? So, these students are solving the same problem but of different numbers. So, may iwasan ngayon yung pagkokopyahan. Right? They might discuss, pero when they solve the problem, they solve it on their own. After figuring out how to do it. Okay, let's proceed. So, working on the first problem, a public utility vehicle started from rest and constantly accelerated at blank meter per second square for blank second. What is its final velocity? So using the I guess, we need to translate these word problems into illustrations. And on the illustration, it might help also that they put the variables here, right? And following the I guess, we have first the illustration and the given, right? So by identifying the units, we will be able to identify what they represent. Meter per second square, that's A, acceleration. Now, started from rest. So take a look at this. It does not state here. It's not stated here that the velocity or the initial velocity is 0, but rather it is presented in another way, like saying it started from rest. Okay, so that's the initial velocity, and blank second, that refers to the time interval. And looking at the question, it seems like the problem is asking for the final velocity represented by V sub F. Okay, so by doing so, we allow them to identify the given first, the concept involved, the variables involved. All right. Then after this given and identifying the principle, then we may proceed with the equation involved with this principle. Okay. So it says here accelerated. Okay. The first equation, this is good for objects that are moving with constant velocity. Okay, so equation number 1 is definitely not a solution or not a formula that will solve the problem. So the equations that include or that involve constantly accelerated motion are 2, 3, 4, and 5. Now, how will this or how are we going to use this equation? How will I guess help the students in choosing the right equation to solve the problems? So here's how are we going to use I guess. Okay. Given the information, acceleration, delta t, initial velocity, and the unknown, particularly the unknown, we'll focus on equations that include what is being asked. Okay, so let's try to evaluate the equations. The second equation includes the unknown. So there's a possibility that equation 2 might be used. Equation 3 also includes the final velocity. And so with equation number 5. Now, ang tanong, alin dito ang gagamitin natin? Okay? So we will consider again the other relevant information given in the problem. We have acceleration, initial velocity, and time interval. So let's try to evaluate this. So from checking the equations that includes the unknown, matatanggal ang equation 4 at kanina natanggal na rin ang equation 1. So we are limited to 3 equations. Now let's try to evaluate each equation. Number 5, okay? D, question. In the given, do we have the displacement? Wala. Tama. Wala. Okay? So kung wala, what does that mean? So we cannot use equation 5 alone to solve for VF. Right? So we try to reconsider other equations. Equation number 3. VF squared, that's the unknown. Initial velocity, do we have initial velocity? Let's check on the given. Yes, we have. How about acceleration? Yes, we have. Displacement? We don't. Okay, we don't have. So what does that mean? Can we use equation 3 to solve the problem? The answer is no, particularly if you're only going to use this equation. Okay, because in this equation, there are 2 unknowns. And in mathematics, if there are 2 unknowns, the minimum number of equations are 2. Okay, or is 2. Now, let's try to evaluate equation number 2. VF, VI. Do we have VI? Check. Do we have acceleration? Yes. Do we have delta t or time interval? Yes. So we have all of this information, and it also includes what is being asked. So the final question is, can we use this equation? Of course, yes. So the equation that we're going to use to solve the problem is VF is equal to the initial velocity plus the product of acceleration and delta t. Nakuha? Okay? I-evaluate natin yung mga possible equations that can solve the problem. Kapag dalawa ang kulang, then hindi natin sila pwedeng gamitin na mag-isa lang unless we use another equation. Okay? Now, paano natin to i-evaluate sa teachers? So given this, since we will use this uh, numberless problems in their drills, so we can stop until the final equation. Okay, but to complete, I guess, so for the solution, we just need to plug in the possible values na pwedeng manggaling sa inyo, teachers, or manggaling sa estudyante. Okay? VI, so we put VI, we put acceleration, we put delta T. And lastly, the statement answering the problem. Okay? What is the final velocity? Simply, the final velocity of the PUV is blank. Okay, suppose we have numbers. We have already uh, indicated information, exact acceleration and time interval for the problem. Okay? So, i-apply ulit natin. A, based on the unit, meter per second square. So, that must be the acceleration. 0, since it started, it states here, it started from rest, and the time interval is 5 seconds. So given this equation, again, for our solution, we just need to plug in the values. VI, 0, acceleration, 3 meter per second square, time interval, delta T, 5 seconds. So manipulating the equations, calculator answer, we get 15 meters per second. And statement, the final velocity of the public utility vehicle is 15 meter per second. Does it make sense? Okay. 3 meter per second square, meaning to say it's moving, it's accelerating 3 meters per second for over 5 seconds. Okay. Now, if that's the case, the final velocity starting from 0. So 0 after 1 second, it's 3. After another second, another 3 plus 3, so that is 6. Another second, 9. After 4 seconds, 12. After 5 seconds, 15 meter per seconds. Does make sense. Okay. So second problem. This is on math. A tower stands vertically on the ground from a point on the ground which is blank meter away from the foot of the tower. The angle of elevation of the top of the tower is blank degrees. What is the height of the tower? So if we're going to illustrate or show symbols, so not necessarily ganyan yung i-drawing, okay, ng estudyante, but at least they can visualize the problem. Okay? They can represent the problem. They can illustrate something to represent what is given and unknown in the problem. Okay? The first step is illustration. And in the problem given is the angle of elevation. Okay? And the adjacent side at blank meters. And the height. Okay? And also, we are asked to solve for the height, I should say, which is the opposite side. Now, in this topic in math, it is very essential that the adjacent and opposite side is always relevant or relative to the angle given. Okay, so this adjacent side is adjacent to the given angle. And this side of the triangle is opposite to the given angle. Meaning to say, if the angle is here, angle of depression, the adjacent side is the height and the opposite side is the distance from this point. Okay. Now, the problem involves right triangle, and the possible equations for right triangles are the following. If you are familiar with this, the SOHCAHTOA, sine theta, opposite over hypotenuse, cosine theta, adjacent over hypotenuse, tan theta, adjacent over opposite. Okay, that's the starts of the letter. Ka, CAH, to, I'm sorry, TOA, that is opposite over adjacent. Okay. Now, let's try to, sorry, okay, we presented it wrong. It should be opposite over adjacent. That stands for TOA, right? Now, and by solving the problem, we simply plug in the values. Though prior to solving the problem, we just allow the students to work out on the problem first, to work out which equation to be used. Okay? Now, by evaluating this, by evaluating the given and unknown, we know that the equation to be used is equation number 3. For what reason? Because what are involved in the problem is the adjacent side, the elevation angle, and the opposite angle. And looking at the equation, all of them involves angle, but let's try to take a look at the other information. Equation number 1, opposite. Do we have the opposite side? Yes, we have. Hypotenuse? Unfortunately, we don't. Okay, since we don't have the hypotenuse, then we cannot use equation number 1. Equation number 2 as well includes hypotenuse. Okay? So we cannot use equation number 2. Equation number 3 involves the opposite and the adjacent. So on this case, we have all the information that we need, then we can solve the problem. Okay? So excuse me lang ha, this is baliktad. It should be opposite over adjacent. Okay? Okay, now supposedly we have these numbers. It's 48 meters and the elevation is 30 degrees. Again, we have the illustration. The given is angle is 30 degrees. The adjacent side is 48 meters. And we are to take a look at the height or the opposite side of the triangle. Okay. Which equation to be used? It's, I'm sorry, it's opposite over adjacent. Now, opposite over adjacent, so the height now will be adjacent, uh, height represented by the opposite side. Okay. I'm using a pen here. So height, sorry, this, which is the opposite side. Okay. So if we're going to write this as height, this will now be the height, and this is the adjacent side. So to solve for height, now, we cross multiply this. So height is equal to the adjacent side, which is 48 meters. 48 meters multiplied to tangent theta. Okay. It should be opposite over adjacent. Okay. Since we're looking for opposite, we just need to cross multiply this. Okay. Manipulating the equation, you can use your calculator to solve that problem. Okay. But likewise, we use the same procedure. Okay. We illustrate for us to visualize the problem. Okay. And then based on the problem, we identify what are the given, including the representation, okay, and the correct units. And also, we use we determine what is being asked. Given this problem, we can now identify the equation that includes the principle involved, and that is right triangle. Though here, there are several equations. What we're going to do next is again to evaluate each of the equation. Ouch. All right. So there's a technical problem a while back. Okay, so let's proceed. Okay. Now, the height of the tower is approximately, definitely, this is no longer the final answer since it should be, or the height is 48 meters times or multiply to tangent 30 degrees. Now, I guess it's your turn to try to apply this. I apply the I guess. Okay, gawin po natin, subukan natin. Okay, so one, illustrate. So what does the problem look like? Okay. A car travels on a racetrack at a speed of 45 meters per second and slows down at a constant rate to a speed of 25 meter per second over 6 seconds. How far has the car moved during this time? Okay, trying to picture out ano itsura. Okay, so you can just simply, we can adapt what we had a while back. Okay, and for students, you may write the given and unknown in the illustration itself. Okay, for you to figure out what the problem is all about. Okay, so what does this 45 meters per second represent? What does constant slows down at constant rate represent? And how about this 25 meters per second and 6 seconds? Okay, so bumagal daw. So initially, the given information are the following. Okay, you're done. With G, the given are, okay, you are correct. Okay, So it's initially moving at 45 meter per second and it slows down at constant rate. And at this point, the final velocity after 6 seconds is 25 meter per second. So this deceleration of the object happens within a 6-second time interval. And what is being asked? You, from the term how far or from the lingo how far, it implies we are asked for the distance or displacement. And you are correct. Okay? That's D. Now, it states here that it is slowing down at constant rate. Right? So it involves constant acceleration. So it involves equations that includes constant acceleration. Now let's try to check it out. Again, equation 1 cannot be used because this is, or the limitation of this equation is for object or objects moving at constant speed. Only the equation 2, 3, 4, and 5 are involved in problems involving constant acceleration. Now, with the given and unknown, try to identify which equation are we going to use to be able to solve the problem. Can we use equation number 2? You are correct. We cannot use equation 2 for the reason that we do not have acceleration in the problem. Using equation 2 alone will not solve the problem because there are two unknowns, A and the final velocity. Equation 3, and on the first place, equation 2 does not involve what is being asked. Okay, I'm sorry, VF is given, but it does not include the variable that we wanted to find out. Equation number 3 involves D, D, and D. But again, we have to analyze which equation will be used based on the given or relevant information. Can we use equation number 3? Yes, you are correct. We cannot because again, we do not have acceleration and displacement, or simply there are two unknowns in this equation. Can we use equation number 4? Tama. Hindi natin pwedeng gamitin ang equation number 4. Do we have VI? Yes. Delta T? Yes. Acceleration? No. We do not have acceleration. So meaning to say, we cannot use equation 4 alone to solve the problem unless we solve for the acceleration first. Can we use equation number 5? Now, let's check. Okay. Do we have VI? Yes. Do we have VF? Yes. Do we have the time interval? Yes. Okay. If if all of these are given, then can we use this equation? Definitely yes. So the equation to be used in solving this problem is equation number 5. D is equal to V plus VF all over 2 multiplied to delta T. Okay? In the event that your students were able to arrive at this stage, then we can give them 1 point, 1 point, 1 point, 1 point, 4 points. Okay? So that will be a prerogative of the teacher. Okay? But the thing is, we have to recognize at which stage are our students uh, uh, position in the in solving the problem. Okay? They may not be able to get the correct answer, but we have to recognize what they know. Okay? And by doing so, by giving them credit, okay, it will give them somehow confidence to go on with another problem. Okay? Magkakaroon sila ngayon ng kumpiyansa na magpatuloy. Okay? And also in the event na magkamali man sila, magkakaroon ngayon ng feedback. Okay? They know kung saan sila nagkamali at alam nila kung ano ang kanilang i-work out. And lastly, solution. So we just need to plug in the values. VI is 45 meter per second. Right? VF is 25 meter per second all over 2 times 15 seconds. And the answer is 210 meters. You are correct. Okay? Statement simply, the car had traveled 210 meters after 6 seconds. Okay? Buha. All right, so I guess that's all for this session. Thank you for watching. Please don't forget to click on the QR code or the given link presented on the screen for your attendance and evaluation. Thank you, and hopefully this video helped you solve addressing the problems on how to improve the problem solving skills of our students. And to our dear students watching out there, hopefully ma-address natin at ma-develop, ma-improve pa natin yung ating problem solving skills. Good luck! See you again next video.